Hello everyone and welcome back to the C Cubed channel. This is a tier 1 video, so this is for GCSE Maths Foundation students and those who wish to start from the basics. So today we're going to be taking a step up from the last few videos where we were looking at linear equations and how to solve equations, and today we're going to be taking a bit of a step further into looking at inequalities, more specifically the linear inequalities. There's a different kind of inequality we'll be looking at in the graph section. We'll be plotting them out. And in this algebra playlist, we'll also be taking a look further into the quadratic stuff. But to begin that, we need to go over quadratics, obviously. So we're not going to do that just yet. So this is going to be very basic, just simple linear equality stuff. So to begin with, we have to understand the idea of an inequality notation. So we need to know what symbols we use for inequalities. And we have these four right here. So they're quite easy to understand, well, they're quite easy to use. Eventually you'll probably end up using this a lot. In the science, physics-y area, we're going to be seeing this notation quite often. For maths also, see it quite a bit as well, but not as much. So basically what these are is we have these kind of square or triangle brackets, and we just simply say that this one here is less than, this one over here is less than or equal to, this one here is greater than, and this one here is greater than or equal to. So that's basically all these symbols mean. It's just one is less than the other, or one is greater than the other, one is less than or equal to the other, and then one is greater than or equal to the other. So we can see how these are used. So for example, we have in this situation we say that x is less than 2. So what this means is that any value of x could be, like let's say, we've already defined a variable here, x, right? And x could be a number. But in this situation we've restricted it such that x can only be less than 2. So it's any number that is less than 2 and is not equal to 2 as well. So if we were to do this on like a number line, let's say like that, it's a pretty bad number line, and we have a number here, so let's say 2, and then this is 0. What we say here is we do a little circle to say that that is kind of like the boundary point, and then everything goes, you put an arrow going to the left. And so this basically means that x is less than 2. So it accepts all numbers that are not equal to 2 and above. That's what x is less than 2 that's what it means. We could say the same for x is greater than 2. So let's do a double line again. Let's do 0 and 2. And now again put a little circle, but instead of going towards the left, we're now going to go towards the right. And this physically means that it will accept all values of x that are bigger than 2 and not equal to 2 itself. So we are accepting all the numbers that are larger than 2, so bigger than 2. And that's what this physically means, x is greater than 2. And we can show that like this as well. Now, I haven't used the less than or equal to, greater than or equal to notation in this slide, but we're going to quickly add it on. So let's say that this is now, oh, that's a bad, excuse me. There we go. So let's say x is now less than or equal to 2. So what this means is that x can now be 2, but it still has to be less than, it has to be less than the boundary. So what I mean is, we're saying that x is less than 2, and it's also, or, it could also be equal to 2 itself. So to demonstrate that, we just shade the circle in to say that x is now less than or equal to 2. So x could be like, say, 0, 1, -5, -10, and it can also be 2. That's what it means. Similar situation here, we have x is greater than 2. We can say x is greater than or equal to 2. And it's the same situation. X could be equal to 2, or it could be equal to 3, 4, 5, 6, etc. And to demonstrate that, we just shade in the circle. And that's all there really is to the inequality notation in this way. That's basically kind of the starting point for knowing this kind of thing. So let's take a look at this now. If we combine if we have a kind of a combination now, so we're going to restrict x to two different areas now. So in the last situation, we said we restricted it to one limit, and that's it. So x can only go up to 2, and then that's it. And in this situation, x can only go down to 2, and then that's it. In this situation, we have two limits now. We have two boundaries. So let's see how we can quickly define this, or how we can like understand this. So 2 is less than x, which is less than 6. That's how you read it. And what I mean is, if we to make another number line, we have 2 there and 6 there, right? And what we're saying is that basically x can only exist between 2 and 6. And because there's no equal sign underneath these, that means it cannot be 6 or 2 either. So it has to be, 3, 4, 5, and then whatever number in between, decimals. That's all it can occupy. So if we were to draw this out, we would have circle, circle, and then the line across. And that basically just shows, okay, so these are all the regions. This is the whole region where x could be. And it cannot be 2 or 6. Now, if we were to change one of these to an equal, so 2 is less than x, and less than or equal to 6, then you would just shade in 6 to say that, x can only be, x can only be between 2 and 6, but it could also be just 6. And the same would happen if we just put the thing under 2, I put equal between the left one here, and got rid of this one, then you would say, it could be between 2 and 6, but it can also be 2. And if you put them for both, then you could say it's between 2 and 6, and it could be either of them. It could be 2 and 6. So that's kind of like the standard procedure for that kind of thing. That's how you would read this kind of thing here. And then for a general case, we have an x between a and b, and this follows the same kind of deal. If we're to draw it out, we got a and then b. And if in this situation, put 2 circles, and then just quite simply like that. Done. And x could exist between a and b, but they cannot be a or b. So that's what that means. So that's how you read the inequality notation. That's how you understand the inequality notation. It would be good to kind of practice a little with making your own kind of inequalities in this form or in this form. Just so you can kind of mess around the number line to see what regions x would accept, because that's very essential to keep in mind. Because for example, you have to make sure like the numbers are correct as well, because if you said 6 is less than x, which is less than 2, then that'll be a little odd in a way, because you're saying that I mean you're kind of going to be reading it the other way around, and that's a bit strange. I mean, it could make sense, but typical form is just make sure you know what you're writing basically on the numbers. Like make sure you have it ordered. If you're using actually in a way that could actually work. You just have to flip the signs around, I guess. But what I'm trying to say is, if you have the less than signs here, smaller than, then make sure you have the smaller number on the left and the bigger number on the right in this situation. And if you were to swap the numbers around, then you'd have to swap the signs around as well. So that's basically all I'm saying in that case. Okay, so we're done with that. Now let's take a look at linear inequalities. This is what the actual lesson is about. So what is a linear inequality? So basically, this is an inequality that contains a linear function in it, or an expression, or any kind of like linear expression. So basically anything that's just got x on its own like this. So we've got 3 examples here. 3x is less than 2. That is a linear inequality. 5 is greater than or equal to x plus 1. That is also a linear inequality. And then 4 is less than or equal to 2x, which is less than 8. And that is also a linear inequality, because they all contain just x, and no powers of x, no squares, cubes, or any of that. So this is just a standard linear inequality. Simple as that. So what these do is basically that you can kind of see these as equations in a way, except instead of them being equal to just have these different less than, greater than signs now. So how do we solve these? So let's go ahead and solve some linear inequalities. So we got the two that we saw in the last slide, these two. So we're going to go ahead and solve these very quickly. So to solve a linear inequality, you basically just carry out a standard procedure of solving an equation. Quite simply, as simple as that. So we just treat this as an equation, in a way. So in this case, 3x is less than 2. We want to isolate x. We want to get x on its own. So we just simply divide both sides by 3, as we have done with equations and other things. We've done this many times now, so we just simply divide through by 3 on both sides. So remember, if you're not really familiar with this, be sure to check out the rearranging expressions, or the changing the subject session, and also the solving linear equation session, where we thoroughly went over this. So I'll steps here because it's good to kind of, I mean, it wouldn't really be beneficial to keep writing the same things over and over. So that's something you just have to practice on your own, I guess. So anyway, so this is what we get. X is less than 2 over 3. Now, you could leave it just like this, but I would also, I mean, it depends what they ask really, but sometimes they may be asked to draw out the number line as well to show this. So we're just going to quickly do that. It's very simply got a point where you got 2 over 3, and because it's just less than, just do this, oh, that's a bad circle. Do a little hollow circle there with nothing shaded, and then just draw the arrow, and there you go. That's shown. Now it is good practice to do this, so you know which way the values of x are accepted. So it's because x is less than 2 over 3, so it'll be everything smaller than 2 over 3. And that's why we write it there. That's why we draw this, I mean. So next situation. 5 is greater than or equal to x plus 1. So in this situation, we just simply bring the 1 over to the other end. So you get 5 minus 1 is greater than or less than x. And that is just simply 4 is greater than or equal to x. Now in this situation, we can in fact, we can kind of rearrange this. If we want to draw this out on the number line, we've seen so far that all of them have x on the left side. So what we could do in this situation, we could just simply swap this over. So we can read this backwards as x is smaller than or equal to 4. Because what this basically means is that 4 has to be bigger or equal to all values of x. So if we draw down a number line here, we have the value of 4, and x has to be bigger. No, 4, sorry, has to be bigger than all of the values of x. Or it could be equal to 4. So we just do a circle, shade it, and we bring the arrow that way. So this might be a bit weird to understand, but hopefully it should make sense. Because if you set x to say 3, then 4 is greater than 3, and that is on the left side, so that's fine. Set x equal to 2, 4 is greater than 2, and 2 will be on this side, so that is also fine. Say 5, x is equal to 5, then you're going to say that 4 is greater than 5, and that is clearly not true. 5 is greater than 4, so that will be on this end, and that won't work. So that's why you draw like this, even though this is a greater than or equal to sign. So again, we could just simply rewrite this as x is less than or equal to 4, because that's just simply what's happening here. So you could just quickly rearrange that, and that's how you draw it out. Simple as that. Now, when we have negative numbers, that is where we reach some very interesting situations here. So let's just solve this for x like as normal. So what we do in this case, we just simply divide minus 2 on both sides. So we got x is greater than minus 4. Okay, we have something here. So we just said that x is greater than minus 4. Now, what we've done is we basically just divided minus 2 over on both ends, right? And if we were to draw that out, we'd see that we get x, we also put 4, and we said that x is greater than 4. So there's all value, oh god, get all values of 4 greater, oh sorry, that has to be minus 4 even. It's going bigger than minus 4. And we've got 0 somewhere here, I'll say, just for reference. Now, the thing to know, when you're dividing negative numbers, it is always good to, well, there's kind of a rule you have to know here. So let's say we put minus 2 into this. So minus 2 times minus 2 is 4. And what we said here is 4 is greater than 8, which doesn't make sense. 4 cannot be greater than 8, right? But we said minus 2 is bigger than minus 4. So something went very wrong here, and we're going to see what happened. So the idea, the thing you have to know with inequalities when you have negative numbers is when you're dividing or multiplying negative numbers, you have to flip this symbol in the middle, right? So let's go ahead and very quickly erase this for a moment. Let's just increase the brush width here, just so I can erase that middle bit there. Oh, that didn't end up as I had hoped. Let's just get rid of that. And we got a little circle now, but it's fine, don't worry about it. Alright, now I just bring it back down to the brush size I had before. So, in this case, we have to actually flip the side over. Oh, that was bad. So now we're saying that x is less than minus 4. So x, in fact, has to actually be going the other way. And we can erase all of that, don't worry about this, get rid of that. Alright? So, let's see if this works now. So let's say, x has to be less than minus 4. So let's take, say, minus 5. Minus 5 is less than minus 4. So, minus 2 times minus 5 is 10. And 10 is greater than 8. So, that works. So that is why you have to flip the sign when you divide negative numbers or multiply negative numbers, is because you have very strange ambiguity results such as this. And it's really like kind of finicky otherwise. So it's just a general rule to follow, because then your inequalities would be incorrect and then you get all sorts of very weird values. So final example for this video, we're going to do 3x minus 2 is less than or equal to x. So as in this situation, we're just going to group the like terms together. So we're going to do 3x minus x is greater than or equal to 2. And in this case, you just get 2x is greater than or equal to 2. And x is just greater than or equal to 1. So that's all there is for that one. It is just quite simply bring the x over to the other end, bring the 2 to the other end, and then just quickly divide through, and then we get x is less than or equal to 1. So we can just draw that out real quick. Let's get 1. And this is a solid circle, and then bring it down like that. Now, you could also do this a different way. You could bring the 3x over to the other end as well. So let's do that as well. So let's do 2 minus 2 less than or equal to x minus 3x, so you get minus 4x here. Wait, no. Oh no, my bad. That is not correct, even. In fact, what you get actually is... No, yes, you would. No, yeah, that's right. You get minus 2x on this end. I am sorry about that. This mind is getting very slow right now. Yeah. So you get minus 2x on this end. Now what you do, again, you just quite simply divide through everything by minus 2. So you just get 1 is less than or equal to x. So you get 1 is less than or equal to x. And this doesn't make sense, right? So remember, when you divide by minus 2, these two are not the same, in fact, because that basically saying x is greater than or equal to 1. So what we have to do when you divide through by negative numbers, you just flip the sign around. So 1 is greater than, 1 is greater than or equal to x. And simple as that, we are done. Or you could just quickly rearrange that. X is greater than or equal to 1. Oh no, wait, sorry, I had to flip the sign over again. X is less than or equal to 1. And that is the same as that. So that is all I had to really say on inequalities. Linear inequalities, I should say. That's about it for this session. Thank you guys so much for watching. And in the next video, we're going to begin looking a little further into another kind of area of algebra that we'll be looking further into in the future. Again, we will be revisiting inequalities at a later point for the higher tier, GCSE. So it'll be tier 2 videos that will be coming up soon on this. But anyway, thank you guys so much for watching, and I'll see you guys in the next video.